Whenever we talk about AI, we usually get caught up in the amazing things they do, right? The massive neural networks, the incredible results. But what's really going on behind the curtain? There's this hidden engine that does all the heavy lifting. And today we're going to pop the hood and unpack exactly how AI actually learns.
Have you ever really stopped to think about it? How does a machine go from just a bunch of random numbers to being able to see what's in a picture or write a whole paragraph that makes sense? It's a pretty fundamental question.
And the answer? Well, it isn't some kind of crazy, unknowable magic. It's a process, a really clever process actually, called optimization. This right here is the absolute core of how a machine gets better and better at whatever we ask it to do.
So before we can really dig into one of the most popular optimizers ever, Adam, we've got to first understand what an optimizer even is. You can think of it as the tireless personal trainer for our AI model. So what is an optimizer? At its heart, it's an algorithm that's constantly tweaking all the little internal settings of a neural network. We call these settings weights. It's kind of like tuning an old-school radio. You slowly turn that dial, trying to get rid of the static to hear the music clearly. The optimizer is doing the exact same thing, turning thousands or even billions of tiny dials to cut down on errors and get the clearest, most accurate prediction possible.
All right, so let's bring out the star of the show, Adam. Ever since it came out back in 2014, Adam has become the default, the go-to choice for so many developers and researchers. So what's the big deal? What makes it so special?
So ADAM is actually short for Adaptive Momentum Estimation. And believe it or not, that name is a huge clue about how it works. And here's the cool part. It wasn't invented out of thin air. It's a brilliant combination of two other really powerful ideas, momentum and RMSProp. It literally takes the best of both worlds and smashes them together.
So what are these two big ideas it's mashing together? Well, first you've got momentum. Picture a big, heavy ball rolling down a hill. It builds up speed, right? And it can just plow right over any little bumps or dips in the path. That's momentum. It helps speed up the learning. Then you have RMSProp. This one is a little bit smarter about the terrain. It actually adjusts its speed based on how steep the hill is, going faster on gentle slopes and more carefully on the really steep parts. Adam's genius is that it combines that raw downhill power of momentum with the smart adaptive speed of RMSProp.
Okay, I know what you might be thinking. The math behind this probably looks super intimidating, right? But honestly, the core idea is beautifully simple. We're going to use an analogy that I think makes it all just click.
Okay, I want you to imagine something with me. You're a hiker. You're stuck in a really, really foggy valley. And your goal is simple, find the lowest point. The problem is you can't see more than a few feet in front of you, so you have to make all your decisions based on the feel of the ground right under your feet. This is exactly the problem an optimizer is trying to solve. Now this is where it gets really cool, watching how Adam is like our smart hiker. So first, you check the slope right where you're standing. That's step one, computing the gradients. But you don't just rely on that one spot. You also remember the general direction you've been heading downhill, and you remember how steep the path has been so far. That's step two, the momentum estimation. It's keeping an average. Now at the very beginning, your memory's a bit fuzzy, so you don't trust it 100%. But as you take more and more steps, you get more confident in your readings. That's step three, the bias correction. Finally, using all that information, the current slope, your past direction, and your growing confidence, you take your next, much smarter step. That's Adam in a nutshell.
And because of this really smart, intuitive process, Adam has some huge real-world advantages. This is why it exploded in popularity and became the default choice for pretty much everyone. Just look at this list. It's no wonder it's so popular. Adam adapts its learning speed for every single setting individually, which makes it incredibly flexible. It's computationally fast, it doesn't need a ton of memory, and it handles messy, real-world data really well. But the real game changer, the thing that made everyone love it, it just works, right out of the box, with the default settings. That one feature basically helped take deep learning from something only experts with tons of time for tuning could do, to something way more accessible for everyone.
But, like any tool, it's not a magic wand. There's no single tool that's perfect for every single job. And as powerful as Atom is, it's really important to understand where it shines, and maybe where another tool might be a better fit.
This table here breaks it down really nicely. See how Atom is the only one with a yes in both of those first two columns? It's got that adaptive learning rate, and it uses momentum. That's what makes it such a powerful hybrid, especially for really deep networks with what we call sparse gradients. Just think of language models where only a handful of settings matter for any given word. It also gets its smarts from RMSProp, which is amazing for non-stationary objectives. That's just a fancy way of saying a target that keeps moving.
But of course, it's not perfect. There's some interesting research out there that shows that sometimes models trained with Atom don't perform quite as well on new, unseen data as models trained with simpler methods. And even though it works well out of the box, you can still get stuck if you don't get the settings just right for your specific problem.
So what's the bottom line here? It's this. Atom is an absolutely fantastic starting point. It's a powerful, reliable default, but it is not a universal silver bullet. It won't magically solve every single problem, and knowing its strengths and its weaknesses is the key to using it like a pro. Okay, so let's get practical. If you're going to use Atom in your own projects, what do you need to know? First, start with the default settings. Seriously, they're the default for a reason. If you want to squeeze out a little more performance, try what's called a learning rate schedule, where you slowly decrease the learning rate over time. For really deep models, check out a version called Atom W. It can help prevent a problem called overfitting. And the most important tip of all, always watch your metrics to see how your model is actually doing.
Look, Atom was a revolution back in 2014. It completely changed the game, making it so much faster and easier to train these incredibly sophisticated AI models. But this field, it moves at lightning speed. And that just makes you wonder, what's next? What's going to be the next breakthrough in optimization that pushes the boundaries of what AI can learn even further?